So the last part of section 4.1, we're going to deal with function notation. And function notation is used a lot in higher math. And mostly function notation isn't particularly hard. It's just awkward to look at, but it's not that hard algebraically. And in this first example that I have on the screen, I created a function that I called f of x, or f evaluated at x, and I created a function called g of x, or I could read that g evaluated at x. And it asks me to find f of x plus g of x in that specific order, and g evaluated at x minus f evaluated at x at that specific order. How do I do that? Super easy. To figure out f of x plus g of x, I'm going to take the plus sign that's written between the two functions and write it between what I'm going to write to the right of an equal sign. And then after I get that plus sign that's given to me, I'm going to create two parentheses. And in the first parentheses, because f was written first, write what f of x is equal to. And in the second parentheses, because g evaluated at x is written second, write what g is equal to. So the safe way to figure out what f of x plus g of x is to be very methodical. Put the plus sign down, put parentheses, put the contents of the parentheses to match the definitions, and then just simplify. These parentheses really weren't necessary, so I was harping on using parentheses. As you get higher in math, you'll learn when you can avoid parentheses when you're substituting with functions. But since we're at the beginning, I'm going to use parentheses 100% of the time and just drop them when they can be dropped. But if you start to get comfortable, the step of plopping in parentheses isn't always necessary. Both of these parentheses can just be dropped, and then I combined like terms. I took the time to write the terms in a nice order, combined the like terms, and wrote my terms in a nice order. I won't talk through the algebra. We'll do some of our own algebra in a little bit. I just wanted to conceptually show us what to do. The next part asks me to find g evaluated at x minus f evaluated at x. Same strategy. The minus that's between, I'm going to put between, and then I'm going to introduce two parentheses, creating problems like we just did in the last video. In the first parentheses, I'm putting the contents 4x squared plus 8x minus 9, because the g was written first, so what's equivalent to g needs to go in the first parentheses. The f was written second, so inside my second parentheses, I write what f is equal to. And now it's just the same algebra. First parentheses I drop because it doesn't have a minus in front of it, doesn't have a coefficient, it doesn't have an exponent. Second parentheses, I flip all the signs, made the positive 10x squared into negative 10x squared, the negative 3x and the positive 3x, the positive 8 into negative 8, and then I combined like terms. I wrote the x squared terms next to each other, the x to the first power terms next to each other, the constants next to each other, and then I combined the x coefficients and wrote my answer. The next problem is equally impressive or ugly to look at. If I say find h evaluated at x, where h evaluated at x equals f plus g evaluated at x, this just asks me to find f evaluated at x plus g evaluated at x in a really, really sophisticated way. So this horrible instruction is asking me to do exactly what that slightly less complicated instruction is. Similarly, if I say the function k evaluated at x is the g function minus the f function evaluated at x, that's just a more sophisticated way to ask you to find g minus f of x. So if I said h evaluated at x is this, and to find it, I'm just finding f of x plus g of x again. To find f of x plus g of x, I put the plus sign that's between, create a parentheses on either side of the plus sign, and I fill the parentheses up with the appropriate function. The f function's written first, so I put the contents of it I put the f of x, or that's 8x plus 5 in the first parentheses, and for the g of x I put the 9x minus 3. Both parentheses can just be dropped, and then I combine like terms. You'll notice that when I wrote my answers above, I wrote the problem with the answer. That's not really necessary. Probably if you looked at my key, I don't have my key here. If you looked at my answer key, I probably only wrote this part of the answer and didn't write the function part in my answer. But it is what it is. It's probably better to write the function part of my answer, but it's not necessary. You'll notice in this next problem I didn't write the function part. But let's just talk through this next one. I'm asked to find k evaluated at x, which is g minus f of x. That means I just need to subtract the g function and the f function, just like I did up here. I do that by putting the minus sign that's between the functions, creating a parentheses to the left of the minus sign, creating a parentheses to the right of the minus sign, and then filling up the appropriate contents. The first parentheses is going to get replaced by what g is equal to, which is 9x minus 3. The second parentheses is going to get filled up with what f is equal to, which is 8x plus 5. First parentheses I can drop without doing any modification. Second parentheses I need to change some signs. And then I combine like terms. So let's do a few problems before I introduce one last topic. So I wrote functions down for f and g in problems 59 through 62. And 60 said find g plus f of x. I'm supposed to know that when I have that parentheses, that is equal to this form of the problem without a parentheses. So the quantity g plus f evaluated at x is the same as g evaluated at x plus f evaluated at x. To figure out this, I'm going to take the plus sign that's between the functions and put it between two parentheses. For my problem 60, inside the first parentheses, I'm going to put 2x squared plus 5x plus 3. And for my second parentheses, I'm going to plug in what f is equal to, which is 2x plus 3. Now I'm going to drop both parentheses without changing the contents because of the way the problem is set up. Then I'm going to combine like terms. The like terms are the 5x and the 2x, and the 3 and the 3. The 2x squared, that's the leading term. It has the highest exponent, but it doesn't have a term to add or subtract to it. So it's going to be part of my answer. It's actually going to be the first term I write in my answer, but I'm not going to change it. And then the 5x plus 2x, you can't see the plus anymore. The 5x plus 2x gives me a plus 7x, and the plus 3 and the plus 3 gives me a plus 6. Problem 62, let's just do 61 together. Problem 61 asks me to find f minus g evaluated at x, and that's the same as asking you to find f evaluated at x minus g evaluated at x. And I would do that by putting the minus sign that's between the f and the g of x to the right of an equal sign, and I'll put parentheses on either side of that equal sign. In the first parentheses, I'm going to plug 2x plus 3 because that's what f is equal to in this problem. In the second parentheses, I'm going to put 2x squared plus 5x plus 3 because that's what g is equal to in this problem. Yeah. And now I'm going to simplify. Instead of writing the problem down again and again, I'm just going to write an equal sign, and that means everything equals to the line that I stopped writing or the line that I am writing. First parentheses I just drop. Second parentheses I change the signs to drop the parentheses. So I make it 2x squared minus 2x squared minus 5x minus 3. I'm going to write the highest degree term first, and it doesn't combine with anything else, so it's just going to tag along in my answer but not change. And then I'll work on the first degree term and the constant terms. The 2x minus 5x is going to give me negative 3x, and the 3 minus 3's cancel. So I'd say that would be a good answer for problem 61. Oh, let's do 65 together, but not all the problems on this sheet. I just don't think these are, necessary to do so many. So maybe pause the video and try 65, and I'll do it with you. So 65 is longhand for asking me to find f of x minus g of x. And in order to do that, I'll take the minus sign that's between the f and the g, write it down, and put a parentheses on either side. In the first parentheses, I need the new f function, x squared plus 3x minus 5. And in the second function, second parentheses, I need 7x squared minus 8x plus 2. First parentheses I can drop without changing the signs of the contents. I might be sneaky and put a 1 in front of the x squared because I think it's going to help me. Next parentheses I change the signs of the 7x squared from positive 7x squared to negative 7x squared. The negative 8x I changed to positive 8x. The positive 2 I changed to negative 2. And now I combine like terms and write my problem in descending order, should I say. I'm going to combine the 1x squared minus 7x squared. I'll do 1 minus 7 and get negative 6, and I'll leave my x squared. I'm going to add 3x plus 8x and get an 11x. And I'm going to combine the minus 5 and minus 2. Please use your calculator if you can't do these in your head. And I'm probably making 800 mistakes, so I should be using my calculator. One new thing, and I don't think I need to worry about the theory. Let me just jump right into these. 68 asks me to find g plus f of 2, and I'm supposed to know that means to find g evaluated at 2 plus f evaluated at 2. I'm going to put the plus sign down. I'm going to create parentheses on either side of that plus sign. The strange thing about this is inside the parentheses, I'm not going to plug the function with the variable. I'm going to plug the function with the variable changed to the number that I'm asked to change it. So when in the first parentheses, instead of writing 2x squared plus 5x plus 3, I'm going to write 2 times 2 squared plus 5 times 2 plus 3. And in the second parentheses, instead of writing 2x plus 3 for the f, I'm going to write 2 times 2 plus 3. So the variables are going to drop out. And now it's this order of operations problem. Inside the first parentheses, I would need to do exponents first, multiplication second, and then addition last. Inside the second parentheses, I would do multiplication first, and then addition last. Once I get the parentheses down to a single number, I shouldn't write the parentheses anymore. It looks stupid. So the answer to 68 is just the number 28. Let's do 69 together, and then we'll do a problem or two on the next page. So 69 wants me to do f minus g of 3, and that's really f evaluated at 3 minus g evaluated at 3. I'm going to create my template here. I'm going to put a minus sign between two parentheses. In the first parentheses, instead of writing the f function how it's presented, I'm going to write the f function with the x changed to 3. In the second parentheses, instead of writing the g function how it's given to me, I'm going to write the g function with the x changed to 3. Now I'm going to simplify both parentheses down to a single number. The left parentheses, I'm supposed to do 2 times 3, which is 6, and then plus 3. The left parentheses is going to simplify out to be 9. Once I get the parentheses simplified down to a single number, I don't need to write the parentheses anymore. The right parentheses, if I'm simplifying it, I would do the exponent of 3 squared first. 3 squared is 9. And then the multiplication of 2 times 9, which is 18, and 5 times 3, which is 15. I think that comes out to 36. Once I get each parentheses down to a single number, then I don't write the parentheses anymore. And then 9 minus 36, I'm pretty tired this morning. I still think I could do that without my calculator. I think that's negative 27 for an answer. Let's do another one or two of these. Let's do 73 together. It looks hard. So 73, I need to find f evaluated at negative 2 minus g evaluated at negative 2. Negatives make it harder. The subtraction makes it hard. Made my template up. Put a minus sign between two parentheses. In the first parentheses, I'm going to use the f function, but I'm going to change the x's to negative 2. In the second parentheses, I'm going to use the g function, but change the x's to negative 2. If this was a test question, I'm okay with you using your calculator for silly arithmetic like this. If you do these two steps, and your next step is just writing down numbers without showing the detailed work, I don't have any problem with that at all. My first parentheses, if I entered that right, simplifies to negative 7. So if you don't like doing math in your head, if it takes you too long, or if you make too many mistakes, then I don't care. If the arithmetic you do by pressing buttons. As long as you know the theory of how the problem needs to be set up. If this little arithmetic is stuff that, you want to avoid, avoid it. I don't care if you do basic adding, subtracting, multiplying, dividing on your calculator. So that would be an answer for 73. I'll skip the 71, but you can give it a try. And move on to the last page. The last page we did some problems like this. 76 says find k of x equals to g plus f of x. I know that that means to find g of x plus f of x. And to find g of x plus f of x, write my plus sign between two parentheses and fill up the contents. In my first parentheses, I'm going to put what g of x is for this problem, which is 2x minus 3. In my second parentheses, I'm going to put what f of x is for this problem, which is 5x minus 4. These parentheses are droppable, so I'll just drop them. And then I'll combine like terms of 2x plus 5x. That I wouldn't need my calculator for. And minus 3 and minus 4, that I might need my calculator for. For an answer, the 2x plus 5x is going to be positive 7x. The negative 3 minus 4, the minus 3 minus 4 is going to give me negative 7. For now, that's going to be the best answer for this. And then the next chapter we'll learn how to do this. Rewrite it with a factoring. Sometimes I get students that are way too sophisticated, way too advanced for the class that they're taking from me. If you instinctively wrote that, I would never take points off for simplifying in a way that we haven't learned yet. That's correct. This is chapter 5. But if you know that already, you probably should have been in college algebra to start. But thank you for sticking it out this far. I think I'm going to stop the video now. Hopefully I've done enough that you can do the extra problems that I skipped over.